Hi, Algebra 2. This is 6.6 function operations. If you remember back from chapter 2.1, we're going to look and review relations and functions. And if we remember, relations is a set of ordered pairs, and then we had the domain and range. We also had your input or our x values, and then our range was the output or our y values. And so when we put all these together and we get relations with special conditions or that they follow, then we get an actual function. So we're going to look at operations of these functions and what can we do. So again, from 2.1, if you remember from the example on the right, if we have a set of ordered pairs, okay, we want to know, well, the domain. What's the domain? We're going to write, because it's the actual values for the x's or the inputs, we're going to write down -3, 0, 4, 6. Okay, and then the range is the y values. Well, make sure, if you notice that there are 2 5s there, you do not have to write it twice. So our range is -9, -7, and 5. Okay, so special conditions now that we look at these relations, a special relation such that each input, so each x value, has exactly or corresponds to exactly one y value. Okay, some quick examples. If I have my x's and y's, well, for -3 input, and the output becomes a 4. And that's it. If we have 3, input becomes -1. If I input 4, we'll get -1. Okay, now I know what you're thinking. Well, wait a minute, I got -1 for y. It's the x's that really help us distinguish that function. So 3 and 4 are different x's. They do have the same y though, and that's okay. Another way of looking at it is, here's input, here's output. Oh, we input -3 and output becomes 4. We input 4 and output becomes -1. Another way of looking at it in terms of mapping, here's -3, here's -2. Here's 0. Well, that input to 7, but we have 4, and that inputs to 1. So that is a function also. The problem becomes if we have, here's written as points, 4, -1, 8, 6, 1, -1, and 4, 1. If you look, because of this 4 and because of that 4, they're the same x's. They should only have the same y, and we have -1 and 1. So this is not a function. So function notation. Okay, so f parentheses x parentheses. This is f of x. Okay, so x is the input, and then f of x is that output, or the function of some x. So over here in the green, we have f of x is really equal to y. So our problems, if we let f of x equals 5 minus 3x, g of x is just a different function g, -x squared plus 6x, and kx is x over 2x plus 5. We want to find each of the problems. So let's do a couple. K -3. We're going to plug in -3 wherever we see the x. So we have k -3 equals -3 over 2 times -3 plus 5, -3 over -1, which is 3. If we look at b, f of 3 of t, so we're going to go to the f function. F, and then we're going to put 3t in there. So we're going to go 5 minus 3 times 3t. So that's going to give us 5 minus 9t. E. Now we have x plus h in the f function. So what we're going to do is take this, we're going to input it in the f function up there. So f of x plus h equals 5 minus 3 x plus h. Distribute through. 5 minus 3x minus 3h. We cannot combine anything, so there's our values. Okay, and the last one we'll do together, g, and do the k. So if we take the x plus h, we go k. So k of x plus h. So x plus h on top, 2 times x plus h plus 5 on bottom. X plus h, 2x plus 2h plus 5. By simplifying, there isn't anything we can cancel. We have pluses and minuses, so technically this is all together and this is all together. We can't cancel out. So there's our answer. Okay. Go ahead and hit pause. Do C, D, and F and check back in a second. Welcome back. So C, if we plug in 5x, we're going to have to square the 5x, multiply by negative, and then 5x times 6. So negative 25x squared plus 30x. For D, a little bit complicated, but okay. Plug in A for F function, plug in B for the F function, and then we're going to subtract the two. So f of A equals 5 minus 3a, f of B equals 5 minus 3b. So then if you notice up top, right above the expression, we have minus, so you have to distribute the negative, so your answer is here on the right, negative 3a plus 3b. Okay, and the last one, we got to input x plus 3 into the g function. Make sure you square that, or square x plus 3, x squared plus 6x plus 9, then distribute the negative through. Then we got to distribute the 6 through, so we should get negative x squared plus 9. Now we need to look at domain restrictions. In other words, what are certain domains that we can use and what are ones that we can't? So radicals, remember, what can you not have underneath the radical technically? We can't have a negative. Okay? In other words, so inside has to be greater than or equal to 0, and then in fractions, you know the great we cannot divide by 0, so it needs to be greater than, or sorry, it needs to be not equal to 0. So because we can have negatives and we can have positives. Okay. So problems. We need to just find the domain of the functions algebraically. Well, let's just do the first one. Here's a radical 1. 3 is a radical, and that's it. So those restrictions we know have to be greater than or equal to 0. And then 2 is a fraction, so we can't have denominator to be 0. 4 is a fraction. 5 is just a linear problem, so there really is nothing wrong with 5. So let's just start there. Our domain, if you remember, is, if you write it, domain is equal to then all of the x such that we get all real numbers. So it doesn't matter what x's we plug in there, we're still going to get some answer or some y value. Okay. 1. The radical. We're going to take what's in the radical. So we're going to go, okay, x minus 3, that has to be greater than or equal to 0. So if we solve, we get greater than or equal to 3. So our domain, D, we're going to say all the x's such that x is greater than or equal to 3. If we jump over to 3, again, take the 2x plus 5. That has to be greater than or equal to 0. Subtract 5, divide by 2, and we get negative 5 halves. Drop that down, RD, brackets, x, such that x has to be greater than or equal to negative 5 halves. Okay, so there's our radicals. If we go back to 2 and we say denominator, well, we know the denominator cannot be equal to 0. Okay, so we don't want that. So if we solve for x, we know x cannot be equal to 3. So our domain is everything. So we can say all real numbers and x cannot equal 3. 4, take the denominator, 2x plus 5. So again, 2x plus 5. Now this cannot equal 0. So 2x cannot equal negative 5. X cannot equal negative 5 halves. So if that's the only answer, so we know that the domain is the x's such that x cannot equal negative 5 halves, but x's are all other real numbers. Last thing, putting this all together and looking at operations. So now we want to add, subtract, multiply, and then divide, taking each new function. So I'll do 2 of them, you do the next one. If we're looking at, we're really saying f plus g and x, we're just going to add the 2 functions. So we're going to take the f function, which is 4x squared plus 6x minus 9, and add that to the g, which is 5x minus 2. So we get 4x squared plus 11x minus 11. There's no radicals, there's no division, so we have no restrictions. Let's do D. G function on top. So 5x minus 2. The H function, which is x plus 3, which we have here. Notice, we don't have a radical, but we do have a denominator. Remember, the denominator cannot be equal to 0. So we'll go x plus 3 cannot equal 0. X cannot equal negative 3. So we have this domain x is such that we can have all real numbers and x cannot equal negative 3. Hit pause, do the last two. Welcome back. If you look at B, make sure you distribute that negative through. So that's why I put the parentheses. Distribute the negative through each term, so all three. And you should get negative 4x squared minus 5x plus 12. Okay. And C goes back to taking two binomials, multiplying them together, so 5x squared plus 13x minus 6. Notice A, B, C do not have radicals. They do not have denominator, so there is no restrictions on there. And G does have a denominator, so we stated the restriction there. Great job. And always, do your best. Forget the rest. Bye for now.
Traveling in a freighter combi on a hippie trailhead full of zombies.